Hello, I'm Brian Farrell, and welcome to the session on WAN Technologies Part 4. Today I'm going to be discussing the difference between circuit switched and packet switched networks. Then I'm going to move on to a discussion comparing frame relay versus asynchronous transfer mode. And then we're going to conclude with multi-protocol label switching. There's a whole lot of ground to cover, not a whole lot of time. Let's go ahead and begin this session. Let's begin this session by talking about circuit switched and packet switched networks. Circuit switched networks have a dedicated circuit between two endpoints that is used for communication. While set up, the circuit can only be used for communication between those ends. Circuit switched networks are most common in networks with leased line communication channels. They're best used when there needs to be a fair amount of continuous data traffic between the two endpoints. And with circuit switched networks, there is only one path for the data to take. On the other hand, in packet switched networks, data is broken up into smaller chunks and moved through the network, only to be reassembled at the other end. The data is routed using the destination address, and the data may take different paths through the network that it's traveling through. As a general rule, packet switched networks are less expensive to maintain. Why? Because the user doesn't have to maintain a dedicated circuit 24/7. They're only paying for what they're using. Now let's talk about the differences between frame relay and asynchronous transfer mode. Frame relay is a WAN technology in which variable length packets are switched across a network. Frame relay is less expensive than leased lines, but frame relay can be made to look like a leased line through virtual circuits or VCs. A frame relay network will track a VC using a data link connection identifier to identify the ends of the VC. There are two terms associated with frame relay that you should be aware of. The first is access rate. That is the maximum speed of the frame relay interface. The other term is the committed information rate, the CIR. That's the guaranteed bandwidth that a customer receives. So that's the minimum speed of that frame relay network. The access rate may be higher, but the customer is always guaranteed the committed information rate. Now let's talk about asynchronous transfer mode, also known as ATM. ATM is a WAN technology in which fixed length cells are switched across a network. These cells are always 53 bytes long. ATM can handle real-time voice and video because it's very fast, but it has poor bandwidth utilization. The small cell size reduces the efficiency of the technology, but ATM is very fast even if it is inefficient. Common speeds on an ATM network are 51.84 megabits per second and 155.52 megabits per second. Let's conclude with multi-protocol label switching. The acronym for multi-protocol label switching is MPLS. MPLS is a topology that's growing in popularity. Why? Because it's scalable. Also, it is protocol independent. MPLS can be used to replace both frame relay switching and ATM switching. It can be used to packet switch both frame relay and ATM network traffic. This allows MPLS to be used with both frame relay and ATM technologies. MPLS is often used to improve quality of service and flow of network traffic. It uses a label edge router to add MPLS labels to incoming packets if they don't have them. The label edge router then passes those packets onto a label switching router or LSR router. The LSR forwards those packets based on their MPLS labels to their final destination. Now that concludes this session on WAN Technologies Part 4. I talked about the differences between a circuit switched and packet switched network, Then we moved on to frame relay versus asynchronous transfer mode, and we concluded with a brief discussion on multi-protocol label switching. And welcome to PACE IT's session on Networking Services and Applications Part 1. Today I'm going to be discussing the basics of the virtual private network, and then I'm going to move on to protocols used by virtual private networks. Now there's a whole lot of stuff to cover, so let's go ahead and begin this session. Of course, I'm going to begin by talking about the basics of the virtual private network. A virtual private network, or VPN, is used by remote hosts to access a private network through an encrypted tunnel through a public network. Once the VPN connection is made, the remote host is no longer considered remote. It's actually seen by the private network as being a local host. There are many advantages to that, but I'm not going to cover them right now. Even though the network traffic may pass through many different routes or systems, it's seen by both ends as being a direct connection. The use of the VPN can help to reduce networking costs for organizations and business. The cost reduction is partially achieved because the VPN doesn't require the use of a dedicated leased line to create that direct connection. There are several different types of VPNs. There is the site-to-site VPN, which allows a remote site's network to connect to the main site's network and be seen as a local network segment. VPN concentrators on both ends of the VPN will manage that connection. Then there's the remote access VPN, which is also called a host-to-site VPN. It allows select remote users to connect to the local network. A VPN concentrator on the local network will manage the connection coming in from the remote users. The remote system making the connection uses special software called VPN client software to make that connection. The third type of VPN is the host-to-host VPN, which is often called an SSL VPN. It allows a secure connection between two systems without the use of VPN client software. A VPN concentrator on the local network manages the connection. The host seeking to connect uses a web browser that supports the correct encryption technology, which is either SSL or more likely TLS, to make the connection to the VPN concentrator. It's time to discuss some protocols used by the virtual private network. The big protocol for VPNs is called Internet Protocol Security, IPsec, which isn't actually a protocol in itself, but a whole set of protocols. IPsec works at layer 3 of the OSI model or above. It's the most common suite of protocols used to secure a VPN connection. IPsec can be used with the Authentication Header Protocol, or the AH protocol. AH only offers authentication services but no encryption. So it authenticates the user, but there is no encryption of the session. Or IPsec can be used with Encapsulating Security Payload Protocol, or the ESP protocol. ESP both authenticates and encrypts the packets. It is the most popular method of securing a VPN connection. Both AH and ESP will operate in one of two modes. The first mode is transparent mode. That is between two devices, as in a host-to-host VPN. Or they can be used in tunnel mode, which is between two endpoints, as in a site-to-site VPN. IPsec implements Internet Security Association and Key Management, ISACAMP, by default. ISACAMP provides a method for transferring security key and authentication data between systems outside of the security key generating process. It is a much more secure process. Then we have Generic Routing Encapsulation, GRE. GRE is a tunneling protocol that is capable of encapsulating a wide variety of other network layer protocols. It's often used to create a subtunnel within an IPsec connection. Why is that? Well, IPsec will only transmit unicast packets. That's one-to-one communication. In many cases, there's a need to transmit multicast, which is one-to-some communication, or broadcast, which is one-to-many communication, packets across an IPsec connection. By using GRE, we can get that accomplished. Then there's point-to-point tunneling protocol, PPTP. This is an older VPN technology that supports dial-up VPN connections. On its own, it lacked native security features, so it wasn't very secure. But Microsoft's implementation included additional security by adding GRE to point-to-point tunneling protocol. Transport layer security is another common VPN protocol. TLS is a cryptographic protocol used to create a secure encrypted connection between two end devices or applications. It uses asymmetrical cryptography to authenticate endpoints and then negotiates a symmetrical security key, which is used to encrypt the session. TLS has largely replaced its cousin, Secure Socket Layer Protocol, and TLS works at layer 5 and above of the OSI model. Its most common usage is in creating a secure encrypted internet session, or SSL VPN. All modern web browsers support TLS. Now, I just mentioned Secure Socket Layer, or SSL. SSL is an older cryptographic protocol that is very similar to TLS. The most common use is in internet transactions. Why? Because all modern web browsers support SSL. But due to issues with earlier versions of the protocol, it has largely been replaced by TLS. SSL version 3.3 has been developed to address the weaknesses of earlier versions, but it may never again catch up to its cousin, the TLS protocol. Now that concludes this session on Networking Services and Applications Part 1. I talked about the basics of the virtual private network, and I talked about protocols